The next sorting algorithm we want to discuss is the merge sort. This merge sort algorithm gives you an n log n operation for the sorting problem, which is considered as the best performance that you can achieve in the regular sorting methods. We will discuss several n log n sorting algorithms, including the one that we already discussed, the heap sort, which is using the build heap operation, build up the heap quickly, and then delete one item at a time until nothing left, so that you can get a sorted sequence. The merge sort we want to discuss today is using a merge idea combined with the recursive approach to achieve the merge sort. The next n log n sorting operation that we want to talk about is the quick sort. It might be the most complicated one because it's not designed for human mind. However, it performs very well in the sorting performances. In fact, many libraries, standard libraries using the sorting algorithms applies the quick sort. But let's look into the merge sort first. So what is a merge sort? By the name, merge sort uses the idea of the merge. So we need to look into the merge operation first. So think about this. Saying that we have a sorted segment and another sorted segment. So this is the precondition. You need to have two segments that are already sorted so that we will be able to do the merge operation. When you have two sorted segments, to do the merge is very straightforward. So looking into this one, you can see that starting with the smallest item for the first segment compare with the smallest element on the other segment. Of course, the smaller one would be the smallest of all, so that we would compare A and H, understand A is smaller, so we need to have an additional array to help us store the information. So in this case, we have A over here, and then we compare. When we find the smallest one on the left segment, we will move to the next one, compare G and H, and understanding that G is smaller. So the index will go to the next one on the left segment, compare L and H, understanding that H is smaller. So we will be able to take H on the auxiliary memory array, so that we will move the index to the next one on the right segment. So we will compare L and I, understanding I is smaller, compare L and M, L is smaller, compare O and M, M is smaller, and then compare O and S, understanding O is smaller, so that we will move to the last one. You see that at this stage, when R is being placed, that is saying that the left segment has been completed. And therefore, whatever you have left on the right segment would simply copy and paste, because there's nothing to compare with anymore. So this is the idea of the merge. I want you to make a very quick practice on this numerical example, so that just bring a pen and paper, try to see how does the merge happening in these two segments. You don't need to submit this as an assignment because they are pretty much simple. Just give yourself an experience of how do we merge the two things together, and that's going to be good enough. Assuming you come back for the video, let's take a look of the next slide of the merge sort. The idea is this. Now you understand the merge. However, it requires you to have two segments that are already sorted. So looking into this example, we have a sequence of numbers over here. They are of course not sorted. If we cut the whole thing into half, they are still not sorted. And therefore you are not able to use the idea of the merge sort. Of course, some students may think about this. Say the whole segment has been cut into half, and then we can apply insertion sort on the left side, apply an insertion sort on the right side, and then try to merge the two things back together. That of course will work. However, the merge sort itself is not efficient. half of the n apply on n square operation still give you the n square operation. So it's not going to be as easy as cut the whole segments into half and then try to sort the things and merge them together. In fact, we need to use the idea that we have learned earlier in the insertion sort. Thinking about this, when we were doing the insertion sort, we start with the index of 1, which is the second element. Why is that? Because when you have only one item, it is sorted. So the idea is this. When we're trying to deal with the segments, we still split the two things into half and half. The things is that we try to merge one item and another one item, which is saying that 75 and 55, we first of all merge the two. We merge 15 and 20. We merge 85 and 30. We merge 35 and 10, etc. Once they have been merged, we actually getting a two item that are sorted. So this is a segment with two items. This is sorted, this is sorted, this is sorted, this is sorted. And then we try to merge the next two elements. And in that case, you can see that we will form a sorted segment with 4 items. And then we can merge the 4 item and 4 item, another 4 item and 4 item. And finally, we would have 2 sorted segments that contains half of the elements, and we try to merge them together. So basically, you can see that this merge sort is very easy to understand because you only have 2 concepts. The first concept is the merge idea. The next concept is that you need to have sorted segments so that you're starting with one item with another one to form more sorted segments, and then you try to merge them together. And that is the merge sort idea. Pretty straightforward, pretty easy. If we try to take a look of the code, it is pretty straightforward. So let's take a look of this merge sort function. This merge sort function takes one array and then try to identify the beginning of the location and the end of the location that you want to sort. Inside of this merge sort function, it is a recursive function. So take a look of this one. int middle value, it will give you try to calculate what is the middle index so that you would divide the two things into half. As long as low is less than high, remember there is no equal, so that when you have only one item, which means that 0 and 0, that means it is one item left, so you don't need to do anything. And that, of course, gives you the base case scenario. Otherwise, you hit the general case scenario. So what is the general case scenario try to do? First of all, you try to calculate the middle value, and then you divided the whole segments into 2 halves, and then apply the same merge sort function. So you see that you will use a same array, pass in the low index, pass in the middle index, on the other side, middle plus 1 to the high, and then assuming that they will keep dividing the whole things up, when you finish the recursive call on this one as well as this one, you ideally getting 2 sorted segments, and then you apply the merge operation. So this is a separate operation over here, doing what we discussed as the merge operation, providing the array where is the low index, where is the middle index, and where is the high index. They will try to merge them together. Let's look into a simple example, try to really understand what is happening here. So you see that when we try to say this is a 4 item, and we want to perform the merge sort on these 4 items. So what you're going to do is you pass in the array starting with the index of 0 goes to the index of 3. So when this is happening, it will try to calculate, because it's the general case scenario, it will calculate the middle value. The middle value would be 0 plus 3 divided by 2 and get an index of 1. So you will call merge sort the same array 0, 1, the other one recursively A, 2, and 3. And after these 2 recursive functions are done, you should have 2 sorted segments to merge together. So you will have the merge A, 0, 1, and 3. So what's happening when this recursive function is called, the first merge sort recursive function will call the same function, and then understanding that they are not the base case scenario, so you will call the general case scenario, call the merge sort A00, 0, because the middle index is 0 now, and then call another merge sort A11, and then try to merge the two sorted segments. Of course, merge sort A00 will call recursively and then hit the base case scenario, which basically doing nothing, because 0, 0 is indicating that we have a value of 5, which you only have one item. It's sorted. We don't need to bother that. The next one is doing the same thing. You will see there's only one item, so you don't need to do anything. And then when it comes back, you try to merge the two values. So 5 and 3 are two sorted segments. They will be merged together, becomes 3 and 5. Next, we will see the next merge sort 2 and 3. It will do the same thing. It will call recursively, try to see that there's only one item on index of 2 and there's only one item on index of 3. So the two things hit the best case scenario. The two things will be merged together, so they will become 1 and 2. And finally, once that is done, we will come to the merge operation. So when the merge operation is happening, the two segments 3, 5 and 1 and 2 will be merged together, and you will end up with 1, 2, 3 and 5. So that is what's happening in the merge sort operations.